This is Professor Needing, and I am going to show you how to use Desmos in order to calculate a single proportion with a confidence interval, a test statistic, and a p-value determination. We're going to want to use our formula sheet, which shows our confidence interval levels, our test statistics, our z-stars, and our pooled proportion notations. In the first question, it says, a survey claims that 9 out of 10 doctors recommend aspirin for their patients with headaches. So first of all, let's write down a few things that we know as we go through the questions. First of all, we know that the H sub O, or the claim, is that the proportion of those recommending aspirin are 9 out of 10, or 0.9, which also means that our alternative hypothesis is that P is not equal to 0.9. In addition to that, we know that we have a random sample of 100 doctors, so we have an N value of 100. We have a test statistic that says 82 out of these 100 doctors actually gave aspirins, or 0.82. Important that we use the proper notation as we're working through these questions. We're looking to test the claim, and we're looking to use an alpha level of 5%, or 0.05. First thing we want to find is we want to find a z-score in order to make some calculations. So therefore, we'll use the z-score formula and we'll replace with everything that we have. Our p-hat value is 0.82. Our null, or p sub o, is 0.9. We'll divide that by the root of, again, the null hypothesis multiplied by 1 minus the null hypothesis divided by the n value, 100. When I do that calculation in a rounded, I get negative 2.67. I'm going to go to Desmos real fast and make sure that you're putting in a fraction properly. So I'll jump over to my calculator. When you're entering fractions into Desmos, you have to be sort of careful. For instance, if I use 0.82 minus 0.9 and I try to make a fraction with the / key, you'll notice it only makes a fraction for the 0.9. I have to make sure I encompass things inside of a set of parentheses. So if I put parentheses around and then I use the same /, you'll notice that it creates a fraction for me of the entire value. I need a square root here, and you can grab a square root with the keyboard widget, or you can type SQRT. It'll give you a square root. I need a fraction again, 0.9. I'm going to use a parenthesis for my 1 minus 0.9. That'll give me my numerator. I'll hit my / and I'll put 100 in the denominator. There's the 2.66 repeat, or 2.67 negative that I indicated previously. So that, in fact, is our z-score, and now we can write down that we have that z value. So what do we have to do with that z value? Well, if we think about a normal distribution, standard normal, which is on a 0, we know that we have a test statistic that is somewhere between 2 and 3 on the negative side and is attempting to become more extreme. Our job is to calculate the p-value and make a determination from this z statistic. So our next thing to do would be go to Desmos and would be to look for the amount of area which is consumed by negative infinity to negative 2.67. And we're going to put this on a normal distribution because it's a z between 0 and 1. All z values are determined between 0 and 1. So if you're using a TI-84, then you would use the TI-84 directions that you have, or what you've done in previous courses. But again, this is about Desmos, so that's what I'm going to do. So the first thing I do is I go down to my keyboard, I find functions, I look for distribution tab, I look for the normal distribution, and I tell it I would like to distribute a 0, 1. It is the default, but I like to put it in just so I can see it. Click the box which says find cumulative probability right here. We know the minimum is infinity negative, so if you just leave it blank, it turns to infinity negative. We put in negative 2.67 as our upper boundary, and you can see that we get 0.004. This is our p-value right here. So we'll go back and we'll utilize that same value. So we now know that we have a p-value of 0.004. Remember that we had an alpha level of 5% or 0.005. So the determination will be that the p-value is smaller than the alpha level. So therefore, we would reject the null hypothesis in favor of the alternative hypothesis, in that the proportion of doctors recommending aspirins is not 0.9. Now the question is, okay, why is it not, besides the p-value rejecting because we have significant evidence to suggest so? Well, let's go calculate an actual confidence interval level using our other formula here. And let's see what happens where the range of scores actually should be. So we're going to take p hat plus or minus z star, and I think that we'll calculate a 95% CI, because we have to make that choice and the question doesn't say anything about it, so I'm adding it to it. And we're going to multiply that by the z star value for that, and we're going to take that multiplied by the p hat, 1 minus the p hat divided by n. So one thing we will need from the formula sheet is that we will need the z stars, or the z criticals, for a 95%, which is 1.96. So I'm going to go back and I'm going to make those calculations in here. I'll change colors here. So I'm trying to determine now where should my standard levels be. So I take the test statistic at 0.82 p hat. I add and subtract the z star value, which is 1.96. I multiply that by the test statistic, or p hat, multiplied by 1 minus the p hat value, all divided by 100. Remember, these are two different values, one plus and one minus. When we do the minus one, we get 0.745. When we do the plus value, we get 0.895. What this tells me is that to within a 95% certainty, 74.5% to 89.5% of doctors recommend aspirins to their patients. You can see that the original tests that we looked at of 0.9 does not fall within inside the CI, which also gives us a second reason why we rejected that value. When you come back, I will do the same type of thing for you, but I'll do it with two proportions.